Hello, this is the Knightmares. Welcome back to Blocks Aren't Bad, episode 3. We're going to be talking about encoders. So, as you can see in the robot, I don't have encoder wires on the drivetrain, but I do on the turret. So what I'm going to be showing is what encoders are and how you use them. So first, I'm just going to briefly verbally explain what encoders are. Encoders are external cables you plug into your motors, and they let you track the spinning speed of the motor as well as the position they're at. And what that means is the motor is able to tell if it's been turned 2 times, 1.5 times, 3 times, etc. So in code, motors have 4 different modes. Run without encoder, and that basically means that it just provides the motor power without checking any telemetry or anything. Run using encoder, that means that the motor is actively trying to maintain a specific velocity or power output. And then run to position, which means that like a servo, basically you give it a number ticks. Let me show you what that looks like right here. You give it a number ticks. Usually a motor, it depends on the motor, but a 312 motor has 537.7 ticks per rotation. And so if you were to tell the motor to do this, it would rotate 360 degrees one time. I'm not sure what direction, but I know it could be changed. And lastly, stop and reset encoder. This basically just sets the ticks value to 0. So you're basically telling the motor, hey, wherever you're at, that's 0. So we got to start by doing that. This is the wrong motor. Sometimes I get a bug whenever I try to just set it to target position. I have to give it a target position first, which doesn't really make any sense, but it's what works for me. So let's give it a velocity. Yeah, the difference between velocity and power is velocity is independent of power. Meaning that if you tell a motor to go to like 1500 velocity, it will attempt to reach that regardless of the power output. Let's see if my controller will cooperate. Nothing should happen. Okay, so now I'm gonna try to make the turret move. I'll put the turret on screen in just 1 second. I just need to add this in the code. So let's see here. Let's make it to where A sets the position to 250 ticks. So like maybe a quarter rotation. And then this B will set it to 0. Alright, let's see if this works. No, I do not want to turn on correct browsing. Alright. Oh, my controller is not connected. Just give me 1 second. Oh, so I forgot to mention, I did forget to add a velocity. It's a very common mistake because I just made it. But whenever you set target position, you have to give it a velocity or it just won't move. So let's just do 1500. Velocity tends to scale from like 0 to 3000. You could technically make it higher than 3000, but it won't do anything, if that makes sense. There we go. That should fix it. All right. Oh my goodness. The controller is refusing to connect. I might have to get a different cable. Let's see real quick. Alright, I got a fresh cable. Let's see if this wants to work now. So, as you can see, whenever I press A, it goes to position, and when I press P, it goes back to 0. And so, like I was saying, whatever you tell it, let me just do that. So now, I'm going to tell it that that is 0. So that means that if we were to run the same code, it thinks that that's 0. And so, here, let me try. I don't know how I can show you this, but when you have a motor like this, it actively resists movement. So it's not just going to let you move it. Alright, I'll put that back. It's not going to let you just move it, and that's the intention. So I'm going to show you what different aspects, I don't know what the word is, different features of encoders you could use that you may have not known about. So first thing first, velocity. This one's kind of self-explanatory, but I'm just going to show you what happens if I set it to a quite low velocity. As you can see, it's moving much slower. nice and smooth. We could set this target position to whatever we want. We could even make it negative. So if we really wanted to, we could set this to negative 400 and it would start turning in the other direction. And then, just if you're curious, this is what maximum velocity looks like. So pretty violent there, but those are the main features of encoders. Some of you probably already know this. Another feature you could use with encoders, but it's a little trickier to show with a turret, are velocities. So perhaps I could show it with the intake. If you get a motor, you reset it. Let's use the intake for this, and you set it to run using encoder, right? Now, if you were to say set that motor to a specific velocity, it will actively try to hold it. Now, this does require some tuning, but I'm not going to go over that today because that's a bit too advanced for what we're doing. But let me turn this velocity down. I don't want to put too much stress on the turret. So what I've done is I've just added the intake, velocity, run using encoder. So now we're going to see what that looks like. As you can see, the intake is running at a specific velocity, a certain RPM, and the intention is that it will reach this velocity regardless of the battery level. And this is helpful if you have like a shooter. For example, this year's game, Decode, you want to have a shooter that shoots at a consistent velocity, otherwise you're going to miss the goal. So now, some extra things you may have not known about. If you go to DC Motor Extended, you might see some of this crap here. You can set angular velocity. This is PID, which, like I said, we won't cover today, but we will cover this right here, the position PIDF coefficients. And so what this basically means is how much effort it will take to reach a certain position, or the threshold. Let me just simply put it, the higher this p-value is, the more violent it may seem as it's trying to reach a certain target. So let me just see if I can show you that. It's a little difficult to explain verbally. So this is with a value of 5. Okay, just for redundancy, I'm going to remove the intake so it's not distracting. So this is with 1500 velocity, and this is with a p value of 5. As you can see, it's nice and smooth. Now let's see what happens if we increase this to 10. And this is what I'm talking about right here. It's this position coefficient right here. Alright, so let's see what this looks like. It's the exact same velocity, but now it looks a bit faster, even though it's the same velocity. Let's go even higher to 15. And so the reason why this stuff exists is so you can make more controlled and fast turret movements. It doesn't have to be a turret, but in this scenario, it is a turret. I'm going to show you a snippet of our teleop where this is showcased. As you can see, our turret is able to face the same direction and very fast and quickly adapt to it. And that's because of the p-value we gave it. Alright, well that's everything you need to know about encoders if you're a first timer. If you want to know a little more, I will make more videos about more complex and advanced scenarios where you might use encoders, like for example a turret. Alright, thank you for watching.